Welcome to our presentation for International Innovation Competition, INNOCOM 2020. We will present the Innovation Project 197 Mini Mobile Solar Monitoring Station. Before any further explanation, on behalf of my group members, I am Farah binti Abdul Manap, and I would like to introduce the other members. They are Philip Dharmaraj and Julie Shalina Jenny, and we are from Polytechnic Kota Kinabalu, Sabah. In the era of Industry 4.0, various products is embedded with IoT capabilities. IoT is adding value to product and application in the recent years. The Mini Mobile Solar Monitoring Station is developed to meet environment monitoring requirements, especially in specific locality and at specific time of need. It is a project that can be placed outdoor, powered by solar energy, capable to detect and monitor the surrounding temperature and air quality, current and voltage generated to a solar panel. This project works to monitor and ensure that every data is recorded and stored properly. Therefore, this project is very helpful to the community because of its quick, easy and accurate result. So we are moving to the problem statement. People usually use manual method to do a reading, so it is difficult to record the data and need to stay at the station for taking the data. Other than that, the other station is too big and take too much space. Then the station is fit the structure and it's not portable. So by this project, it is designed and developed to facilitate the reading process. Besides, this project can be used everywhere because it is easy to bring and it's portable and it don't take too much space. And now the objective of this project. They are construct and build a mini mobile solar monitoring station to monitor voltage, current, temperature and air quality. To design a system that can transmit the data through the Blink cloud application. To facilitate the voltage, current, temperature and air quality reading process. And the last will be to charge the 12-volt battery. And now we are going to explain on how our methodology in this project. By showing flowchart, it will be used to analyzing, designing, documenting, or managing a process or program in various fields. By start in our flowchart is showing us to have a reading of voltage, current, temperature, and air quality. By having their reading, we will display it through the LCD and also make a connection with Blink Cloud application to have a notification in our mobile. If the reading or voltage over 99%, buzzer and notification will be on. Meanwhile, if they are not, the both indicator will be off. At the same time, if the reading of air quality is over than 200 ppm, the red light will be on, and if not, the green LED will be on. Now, we are showing the interior part of our project. As we can see, in our block diagram, it will contain two sensors, temperature sensor and air quality, and also the supplier voltage that we use as solar panel, voltage detector, and rechargeable battery. In the middle of the block, we can see clearly the main part to process all the function that we use, Arduino Mega, and the output device. It will be the LCD display, buzzer, LED, Wi-Fi module to go through the mobile device by using Blink application. And this slide also, we show our inner part of the project and their connection and also their location. Rechargeable battery, voltage detector, temperature sensor, LCD, air quality Arduino, and their solar. And then this picture is showing us the whole connection between inner and outer of the project. Voltage, the solar, Wi-Fi, and the outer will be the LCD, buzzer, LED, and air quality. The information and literature review obtained are essentially available to assist in the construction and specification of this project. With this ground of established, and the project can be proceeded with guidance and assertiveness in achieving the target marks. So with the comparison of the main device, we are using it to make a good decision. The main devices will be discussed are solar panel, Arduino, battery, charge controller, temperature sensor, voltage sensor, current sensor, and the air quality sensor. So for the first device solar panel, we are comparing three types of panel, and the monocrystalline solar panel is chosen because it has the highest level of efficiency, 15 to 20% compared to the others, and they require less space compared to other type due to their high efficiency. For the second one, for Arduino Mega, it is selected because it has 16 analog pins, bigger flash memory at 256 kilobyte, and standard USB port. Also, the 2560 is much larger SMD chart. And the third one will be, we are choosing the 12 volt 7 rechargeable battery because it is the most common general purpose battery, low cost than other, robust and less maintenance required. And the next one will be the charge controller. We are comparing PWM, pulse width modulation, and MPPT. And PWM charge controller is used in this project because PWM charge controller are a switch that acts between the solar array and a battery, and its function to pull down the voltage of the array near the battery to ensure the battery is properly charged. And then the temperature sensor, DS18B20 temperature is found to be the preferred choice because it has a smaller temperature sensor with a built-in 12-bit ADC. It can be easily connected to an Arduino digital input, and the sensor communicates over the one-wire bus and requires little in the way of additional components. And then we go to the voltage sensor. For 25 volts, voltage sensor is selected because it is very simple but very useful module which uses a potential divider to reduce any input voltage by a factor of 5. This allows the analog input of a microcontroller to monitor voltage much higher than it capable of sensing. And the current sensor, the decision was made to choose ACS 712 current sensor because of the calibrated maximum 25 ampere, and it also have a 45 millivolt ampere output sensitivity. This ACS 712 module can measure current AC or DC current. And the last one will be air quality sensor. We are comparing with the two different air quality, and MQ135 quality sensor is better suited because it can detect a wide range of gases including NH3, NOx, alcohol, benzene, smoke, and CO2. It is with a low cost and particularly suitable for air quality monitoring application. And now we are moving to the programming that we are used. There are 5 types, and they are temperature sensor, voltage sensor connection, buzzer connection with their percentage calculation, MQ135 air quality sensor, and the last one will be the Wi-Fi module. The first one, the circuit for temperature sensor, and their programming. Okay, this one is the circuit for the voltage sensor connection, voltage sensor connection, and their programming. And the third one, we show you the circuit for buzzer and percentage calculation. This one, the circuit, and their programming. And also for the programming, they are for air quality sensor. This one is the circuit of it, and this one is the programming. And the last one, the circuit for Wi-Fi module, and also their programming as well. Okay, in this slide, following is the result obtained for this project when tested in the indoor facility. Okay, so we can see for the 25 degree is the value of the temperature, 19 ppm for the air quality, reading for air quality, and the voltage 73%, and this one we can see as a display of the blink. Okay, and as the result and the output of this project, we will continue with video after this. and then we can go through the first. Okay, then we can go through to the video, the second video. When the battery is full, Blink will receive notification. And then when a quality is more than 200 ppm, the red LED will turn on. Okay, and then the last one. This one is the latest of the reading. Let me connect. Okay, so there are the data results that we achieved for this project. To find the different data for temperature and air quality, we are monitoring at the 3 different places. They are KKIP, at Nexus Karambunai, and also at Sabah Port. With also the difference that KKIP 6 February, Nexus 10 February, Sabah Port 13 February, they are increasing voltage from the taken time 1 p.m. until 5 p.m. There are also the increasing value of temperature, but the decreased value of air quality. Meanwhile, for the data of battery charging, they are increasing value from 6 a.m. to 6 p.m. 0 volt to 5.6 volt, 5.9 volt. After done our project, we are so grateful that the data we made have achieved the objective of the project. So for the references that we use for this project is being shown here. Me, on behalf of my group members, I would like to thank to all the viewers for your attention. Our sincere apologies for any shortcomings throughout this presentation. That's all. Thank you.